Okay, hello everybody. Welcome to the OnShape / FTC 3D Design Workshop by Team Paragon 11311. So in this workshop, we'll cover how to do like basic OnShape and 3D design, and then we'll cover how to manage a team of designers over OnShape and how to use the version control system. And then after that, we'll talk a bit about manufacturing and how to bring the 3D design parts into real usable parts. So let's start off with basic OnShape. So what is OnShape? OnShape is a free web browser-based computer-aided design system. It allows multiple users to access and work on a single design concurrently. It is considered beginner-friendly and easily accessible, but it is also used a lot of the times in a professional sense. So how OnShape works. So OnShape is split into two basic systems, the Part Studio and the assembly. So in a Part Studio, that's where you create the actual parts that you want to make. So all parts in the Part Studio start as a 2D sketch, and then you can extend or rotate it into 3D. So as you can see in the GIF, you start off with a 2D circle, and then it is extended into a cylinder. I could have also rotated it into a donut or into a sphere. So next is assembly. So assembly is where you combine different parts or different assemblies into one big assembly. So this is useful for when you want to test it's useful because it allows you to make a digital copy of your robot or a subsystem in without actually having to build it in real life, which allows you to catch a lot of design flaws that you might have gone past the design process. So it's just convenient because it allows you to have a digital copy of a robot or subsystem without having to actually make it in real life. So next, let's start by setting up an account on OnShape. So just search up OnShape, click the first link, and then once you click the link on the top left, there should be something like make a student account or something like that. Click that and then go through the process of making your student account. So once you've done that, you should be greeted with a screen that looks somewhat like this. So click create a document, name it whatever you want. I'll name it demo because I'm making a demo. And then you should be greeted with something like this. So as you can see, there's part studios and there's assemblies. You can add new part studios, add new assemblies down here. But you should be in a part studio. So now you just go there's a few basic controls we'll go over. So there's right click, which is just drag, change your point of view. There's click, which you can select something, I'll click these things and then I can select them, or I can click the origin, I'll select it. And then now if I want to unselect them, I can either click them, or if I want to unselect everything, I'll just click the void and nothing is selected. And then there's also mouse 3, which is just drag it around without changing your point of view. And then there's zoom in, zoom out. And then after that, there's the view and cube, which is just front view, right view, corner view, spin that way. Yeah, so it's just easy if you lose track of where you are and then you just want to return to base. So yeah. And then default geometry, there's the origin. If you ever took a math course, the origin is the reference point. You know what the origin is basically if you've taken math. And then there's top, right, front. These are just planes of existence. So they're just the default surfaces you can work on. So next is sketch. So when you click sketch, the sketch is essentially the 2D shape maker. It's what you use to make your 2D shape, which you will then bring into 3D. So when you click on sketch, you can see sketch plane. It'll ask you to select one. So the sketch plane is what surface your 2D shape will be made upon. So if I click front and then let's say I make a circle like this, you can see my circle is now on the front plane because I selected the front as my sketch plane. So yeah. And then there's here, we don't have enough time to go through every tool in depth, but here are some basics. There's the shapes, or the default things, what you use to make the shapes. I made a circle. I can also make a rectangle. and then like I can also make like another circle, and then I can also make it like construction form. Construction has to do with extruding, so I'll talk about construction later while we're doing extruding. There's also like fillet. Wow, I made this corner a fillet. Like, wow, it's filleted now. And then like there's also like these, like they're just all more complicated stuff that we don't have the time to explain. So next, let's do the constraints. So you can see that all my stuff, it's not very secure because I can just change its size whenever I want. But we don't want that to be true. So what we do is we use constraints. So let's say I want to make it so that this circle is 2 inches. So what I have to do is I have to constrain it to be 2 inches using the dimension constraint. So basically anything to do with length can be dimensioned, and you can set its length. So like if I want the point between this, the origin and this edge, I can set that to like 2 inches as well, I guess. And then, yeah, that's what dimension is. Along with that, you also are given a bunch of other constraints that are like different. So like I can go equal, right? And I can make these two equal. But like I don't have the time to explain like every single one. So I'll just like just watch, like go to OnShape Learning Center, they have like their own video. So yeah. Now like after they're constrained, you can see they are now black instead of blue. And you want them to be constrained, or else like they'll be flobby and like loose, and then you can just move everything around, and that's bad. Because if you're engineering, you want everything to be like fixed. So I guess now that they're all black, I can show you like, but like, yeah. So you want them to be good so that you can extrude them. So next, I guess we can talk about being over constrained. So if I were to go like, let's make these two circles of equal diameter. Now, it won't like that because I have just done something bad. Like, wait, that's kind of bad because you can't see the outer circle. Okay, let's just say I want to make it so that these two circles are tangent. Why? Okay, well, no, okay, whatever. I'll just, you know what, okay, that's bad for demonstration because the outside circle just disappears. Okay, let's say I want to make it so that this circle and this line are tangent. I cannot do that because I've already set the length and the position of the rectangle, right? So I've set the length and position of the circle, and making these two tangent would be in conflict of the other two constraints I made. So when that happens, everything turns red, while everything to do with the issue turns red, and then you get over constrained, which is bad. So in this scenario, how to fix it, you just delete the constraint that's the problem, which is the tangent. So yeah, you can just delete some constraints, and then the one that's the issue will go away. But like sometimes it will be some like constraint that you can't see, so you have to click show constraints to delete those in specific. So yeah, now we've gone over the basics of Sketch. Once you're done, click the check mark. And then next, let's talk about extruding. So extruding is just you click on a surface, and then you click on an enclosed surface, and then you can bring it into 3D. So yeah, there's like a lot of different like things you can do. Like you can make it symmetric, you can change its direction, like you can change its extrude direction, you can flip it, you can also just change how the extrusion will end. You can extrude up to a face, all those kinds of things. But we don't have enough time. We only have 30 minutes, so we can't go through every single bit of it. But like just know that like you can change all that stuff. And then you can also do like loft, like, oh wait, yeah, I forgot to explain this part. Once you extrude something, the sketch does not like get removed. It does not get deleted. It just gets hidden. Like once you extrude something, it'll automatically hide the sketch. So to unhide it, you click the eye, and now you can see the sketch is back. But it's like if I hide part 1, you can see the sketch is back, which is good. So yeah, if you ever want to hide or show something, you just click the eye next to them. So now we can like, you can also like revolve or you can loft, but once again we don't have enough time for that. I'll just show you how to like, yeah, you can revolve, you can loft. There's like a lot of stuff that you can do, like, yeah. So let's say I were to extrude this circle again, but this time a bit longer, right? And then I were to like make it so that it was now like, since it's in contact with this part 1, it will be defaulted to adding this cylinder to part 1. But that's not what you always want to do. What if you want to make a new part? Then you'll have to click new. Or like, what if you want to remove? Well, then you'll have to click remove, but there's nothing to remove because like, there's nothing on this side, so it'll do nothing. But like, usually you can cut holes into like stuff. Like, if I were to add back this circular portion, right? I can now cut a circular hole into it. So yeah, you can do that with every extrude. These are like universal: add, new, and remove. They're universal to every form of extrusion. Well, every basic form of extrusion, yeah. So check mark. If I were to add, boom. But for the sake of demonstration, I'll make a new part because 2 parts are more useful if you're trying to demonstrate an assembly. So assembly, as we covered, it's just you are making like, it's just how you make it. In here, you just like combine your parts with other parts or assemblies to make a simulation of your robot. So let's start by adding the parts in Part Studio. And then like, I guess like, let's start with insert. So click insert. You can see there's your current, you're in your current document, and then you can, I have no assembly, so I can just click, I can't click anything in there, so I can click Part Studio. But I can go to other documents, and since there's nothing owned by me, there's nothing here, like I have nothing that I have done yet, so. But the public one, that just has like everything. So let's say I want to insert the 10-to-1 planetary thing. So I want to insert the filled planet carrier. And once I've done that, it's here. So now you can see I have all my parts in here. But you can see they aren't very well linked together. So what I want to do is I want to like use these. These are called mates. So what I just did is I used a fasten mate to connect this cylinder to this face. And once I've done that, I click the check mark, and wow, it does not move anymore. And you can see I can do that with here. Like if I wanted to make a revolve mate, a revolute mate, it just makes it so that I can revolve. So now like if I turn this, wow, I can spin this thing without spinning the other side. So yeah, these are just essentially how to define the relationship between the parts in your robot, and also how to combine them. So yeah, there's a lot of other stuff in assembly like grouping, linear patterning, like stuff like that, but I have no time to explain that because we also have to explain teamwork and also manufacturing. So these are just the basics of what you do in like this. Yeah. And then along with that, if you can also insert like, if you go to home, you can also insert parts from the FDC like parts library. All you have to do is you have to email the first Gmail, like whatever. Like Google has instructions on it. If you just search up like how to access the FTC part library, right? You just go like, it'll just give you instructions. Email first, and then just send each email address that needs access. Boom, you're done. And then now you'll have access to like all the commercial off-the-shelf parts. Like you can insert like Go Build a motors or like stuff like that into your assembly. Like they'll give you access in like a few days at most. Okay, so that's it for like the basics of OnShape. We didn't get to cover a lot of the important stuff or the in-depth tools or like the more complicated stuff. We only did a basic overview. So here are some great resources that like will cover all the like different tools and how to do like more complicated stuff that we didn't get to explain, like variables and like mirroring and like all the different types of constraints and stuff like that. There's the OnShape Learning Center, which is a very in-depth guide built by like OnShape themselves. There's like a lot of different courses based off like what experience level you have. There's a teaching tech OnShape course, which I just found on YouTube, and also the basic OnShape course that I also just found on YouTube that goes through every tool. So yeah, those are some like basic tools you can use.
The next section is teamwork, which is essential for the organization and coordination for your projects. This helps you work with multiple people on the same file, which is not possible with several other softwares. First is version control. This helps you organize different versions and configurations. Because OnShape is browser-based, it allows for real-time collaboration among teammates. This is special for OnShape because other softwares may lock files when someone is editing. You can also work on role-based access control, which is similar to the permissions and management when you share a Google document. You can arrange the document to allow specific people to have view, comment, export, edit, link, share, and copy abilities. This makes sure that your team can work together and intellectual property isn't being given to the wrong people. Lastly is follow mode. This allows you to match a user's real-time progress and see what changes are made. The next features are crucial for prototyping. Branching lets you create independent workspace environments to experiment with different versions without changing the original main file. This is helpful for when you want to test different designs or work with teammates without interfering with each other. Merging simply removes the branches that are not needed. Let's do a demo. First, we have Twisty Toy Part 1. If we click on this button here, we can see the versions and history. This specific document is quite streamlined. We just have the start, the changes, and then the main. The filled in dots are the versions, and the not filled in dots are the workspaces where you can make edits. Over here we have version 2. If we click this document and its version and history, then we can see that it has more than one version. Over here we have the red version, and then over here we have the blue version. When we have the third assembly document, if we insert both of them, then we can put them together. However, if I want to make some changes to, let's say, part 2 and maybe change the color, then usually what people would do is delete this part and import and reconfigure everything. With versions, however, this makes it much easier because you can just go into the version graph, click what you want, update it, and then it becomes what you want it to be. So this makes working with other people and collaborating much more streamlined and much easier. That's for branching. Now let's take a look at what you want to do if you want to merge. Let's say that we decide we do not like this red color and we want to just keep the blue one. We can just click this not filled in dot, right click this, and then merge into the current workspace. If we do that, then there is no longer the red version or no longer the blue version, and then the red version is kept. And that's how you merge.
Next is manufacturing. This is where we'll guide you through the process of designing your parts with manufacturing in mind and how to actually manufacture your parts.
The crucial aspect of robotics that will take your designs from the computer screen to the real world is called manufacturing. Before we can manufacture a design, we need to prepare it. This is where slicing software comes into play. Slicing software takes your 3D model and converts it into a series of thin horizontal layers. These layers are then translated into instructions called G-code that tell a 3D printer or CNC machine how to create the physical object layer by layer. Some common slicing software includes Kira, Fusion 360, and Prusa Slicer. Now that your design is sliced, let's talk about 3D printing, a versatile and widely used method for manufacturing parts. 3D printing, also known as additive manufacturing, builds objects layer by layer from materials like plastic, resin, or even metal. The printer follows the G-code instructions generated by the slicing software to create the object. 3D printing is excellent for rapid prototyping, custom parts, and complex geometries because it's both fast and cheap. While 3D printing is great for certain tasks, CNC or computer numerical control machines offer precision and durability that are hard to match. CNC machining is a subtractive manufacturing process where material is removed from a solid block using cutting tools controlled by a computer. CNC machining is perfect for creating parts that need to be strong, precise, and durable. Common applications include gears, chassis components, and mounting brackets. The precision of CNC ensures that your parts fit together perfectly, which is crucial for the functionality of your robot. Finally, let's explore laser cutting and water jet cutting, two technologies that are invaluable for cutting materials with precision and speed. Laser cutting uses a focused beam of light to cut through materials like acrylic, wood, and certain metals. The laser melts, burns, or vaporizes the material along the cut path. It's ideal for creating detailed parts from sheet materials. Water jet cutting, on the other hand, uses a high-pressure stream of water, often mixed with an abrasive material, to cut through metals, ceramics, and composites. It's particularly useful for materials that are heat sensitive, as the process does not generate heat. It's also capable of cutting thicker materials that would be challenging for a laser cutter. The choice between laser and water jet cutting depends on your material and design needs. Laser cutting is faster for more precise and thinner materials, while water jet cutting is more versatile for thicker or more robust materials. To wrap things up, manufacturing 3D designs is a critical skill in robotics that involves a range of tools and techniques. By understanding these technologies, you can make informed decisions on how to bring your robotic designs to life. So, as you continue working on your projects, think about how these manufacturing methods can help you create the best possible version of your robot.
Okay, so that concludes our OnShape/FTC 3D design workshop. I hope you enjoyed the video and learned something new.